Welcome back from the coffee break. Sorry that it was shorter than half an hour, but we cannot wait longer. So my name is Gabriela Tissa. I'm doing my PhD at the Eindhoven University of Technology. And today I would like to introduce you to some of our collaborative study findings that we did together with NTNU and Citi, Sofia, and Michalis. So, just a little bit of background information. Our study had two main pillars, actually. The first main pillar was the relationship between fun and learning. And what do we know about it? Actually, earlier research was rather inconclusive. First of all, is there a relationship between fun and learning? And if there is a relationship between fun and learning, is it a positive or a negative relationship? Now, more recent empirical research is pointing toward one direction, namely that there is a relationship between fun and learning, and that relationship is actually positive. However, as we already talked about a bit about evaluation yesterday as well, evaluation of fun is quite difficult, and especially in this community in the field of child-computer interaction, it was largely focused on self-report. So children were mostly asked after an activity to evaluate how the experience was, and there are issues with this approach. Of course, there are methodological issues whether the self-reports are reliable with children, but the main issue is that if you ask children after they participated in an activity or did something with your design to evaluate it, then it is a single retrospective measure for the whole activity. And then, of course, it is coarse-grained. You can decide to break the learning activity or the activity into shorter periods and intervene and then ask children in between. But first of all, then you will interrupt the learning activity, and second of all, it will still remain coarse-grained. So the other part of our research, or other pillar of our research, was actually the relationship between emotions and learning, and specifically in reflection of physiological data. And what do we know about the measurement of moods and emotions? There are quite a few methods to approach it, and we can broadly categorize them into three broad categories, which are automatic affective recognition, self-reports, and text or discourse analysis. Of course, all of these methods or approaches have their pros and cons, but the good thing is that they can coexist, they can happen parallel or be used simultaneously. And an upcoming field of multimodal learning analytics is actually what they are aiming to do, to combine data streams, data sources to serve as a virtual observer and analyst for learning activities. And this way, this approach complements our understanding on how children learn. And when I talk about data streams, you can think about, for example, video data, thank you. Video data or physiological data, or for example, skin temperature or things like that. So in our study, in our approach, actually we combined two approaches. One was the automated measures, objective measures, and the other one was the self-reports. Good? Okay. So we came up with two very fancy research questions. The first question is, what is the relationship between children's learning and their affective states and processes during a coding activity? In other words, simply, we were interested in the relationship between learning and physiological data. And the second fancy question is, what is the relationship between children's perceived fun and their affective states and processes during a coding activity? In other words, we were interested in the relationship between fun and physiological data. So regarding our methods, to tackle these research questions, we designed a 2-hour-long playful coding workshop to introduce children coding with microbits. and we implemented it into 6 primary school classes. We applied pre- and post-workshop data collection method, and between the pre- and post-data collection, children had approximately 90 minutes to do their coding tasks, which were 3 distinct coding tasks. And in this picture, you can, for example, see that in the second task, children were asked to first program their code. So it shows randomly a sign, which was either paper or scissors or stone, and then they had to put it on their microbits, and then they could play with it each other. Regarding our measures, as you could figure, we were interested in learning, and to address learning, we collected a pre- and post-test, post-workshop knowledge test, and calculated the relative learning gain. To address fun, we collected data with the FunQ after children participated in the workshop. To address effect, we collected physiological data from 2 sources. One source was a wristband, with which we calculated the level of stress and arousal later on. And then we also collected facial data from the camera of the laptops. And then later on, we calculated action units from it and effective transitions. And on that picture, you can see the study setup when children were busy with programming. So the upper left corner, we have the questionnaire. On the upper, left middle, there's still the microbit pegged. On the left hand of the little girl, you have the wristband attached. On the right hand in the middle, you have the mobile phone that collects the wristband data. And obviously, we were collecting the facial data from the webcam of the laptop. And what did we find? Actually, this thingy is the result of the third task, when children were programming the face of a freely selected animal, and it reacted to kinetic stimuli. So if they were shaking it, then it became scared, and if they put it down, then it became happy. But regarding our results, so regarding the first research question and the relationship between physiological data and learning, we applied multiple regression equations, and we found that actually we can link physiological markers to students' learning outcomes. So, for example, we found that arousal coming from the wristband data and the transition between happiness and surprise, which was coming from the facial data, has a positive effect on how much students will learn. Meanwhile, sadness, anger, and stress, and transition between sadness and anger, coming again from the facial data, had a negative effect on how much students learn. Regarding the other objective of the study, the relationship between fun and physiological data, we applied again multiple regression equations, and we tried to link the physiological data to the 6 distinct dimensions of FunQ. And instead of going through all this information, I will just pick one and tell you a little bit more about it. So, for example, let's see stress. Stress is a contraindicative dimension for having fun. What we found is actually that sadness, anger, stress, and transition between sadness and anger contributed positively for the stress factor. In other words, it had a negative effect on students having fun, but the transition between happiness and surprise had a negative effect on the stress factor of FunQ. In other words, it contributed positively to the experience fun. So, what is the conclusion of this study? Why is it interesting at all? First of all, the first conclusion, I think, and main conclusion is that unobstructed physiological data can provide us with immediate feedback without disruption of the learning experience. If you remember, I said that we can use self-reports, but either it is retrospective and showing backwards at the end of the session, or you disrupt the learning process if you are asking children to self-report in between. So this is a solution for that. We also found that investigating fun while learning to code with this multimodal data approach allowed us deeper understanding of learning processes. So we were able to see how fun occurs during learning to program and which physioaffective states can be used as a predictor for fun. And so in sum, we could both predict learning and fun, or link learning and fun to certain physiological markers. And why is it interesting? Well, some of the previous studies, and most of them coming from NTNU and CITIJ, had already focused on the relationship between learning and physiological markers, but the relationship between fun, which is focus point of this community, I believe, has never been investigated from this angle, whether we can link it to physiological markers. And why is it interesting that we can do that? Well, predicting fun from physiological data can be potentially further developed to support timely interventions to increase learning outcomes. Now, as every study, our study had also some limitations, but we are very happy with them because they are pointing toward future work. So the first limitation is that we encountered practical difficulties when collecting physiological data. In our case, when we tried to attach the wristband to the children's wrists, actually, some of the wrists were just so skinny that it didn't attach to the skin. And if it doesn't attach to the skin, you lose data, or you are unable to collect data. But this was about just the wristbands. But if you are about to collect physiological data with children and you would like to use EEG caps or eye tracking glasses, you will face the same issue. And the underlying problem is that these devices are designed for adults. So more suitable devices for child users are really needed to be able to, for us to be able to investigate these things, well, easier and perhaps more reliably. Another limitation is that we, from the 6 dimensions of FunQ, we could link 4 dimensions to physiological markers, and but 2 dimensions not. And the other 2 dimensions that we could not were the autonomy dimension and the loss of social barrier dimensions, and we believe that the reason why we couldn't link these to physiological markers lies in the type of and sort of activity that, namely, children did not have that much autonomy in the activity because it was quite straightforwardly planned. And regarding the social barrier factor, that they were already a class and they knew each other quite well. So we really would like to investigate FunQ and fun in total and all the dimensions in different settings. And this way I'm thinking about, for example, in formal learning environments and informal learning environments. And the third limitation I would like to discuss here with you is actually the thing that this study was a quantitative study. And it would be very beneficial to triangulate the results with qualitative insights to get a more deeper understanding of children's behavior. And when I'm talking about qualitative insights, it could be interviews or observations. Again, I think that we should think about when we are about to plan this sort of studies is what kind of interventions, what kind of interviews do you want to put into practice, because we might as well disrupt the learning activity, which we are trying to avoid when we are about to use physiological data. So this is the end of the limitations section, and actually my presentation as well. Thank you.